Well, I'd like to say good morning and welcome to all of you. I'm very, very excited doing this today, especially because of the theme of decarbonization. And I'm looking forward to great collaboration with everyone, with members of inside the room itself, as well as members on the table. I'm going to start by asking our panel to introduce themselves. I'll just do it left to right, or my left.
Your left.
Hello, everyone. My name is Behnam Gurtani from Green BMG. We work on solar thermal education, and hopefully if we can get some more grants from government on the research and development of thermal systems, solar heating, and mainly by thermal systems.
Okay, then Dr. Philip Ju.
My name is Philip Ju, and I'm a consulting engineer, and we have a company called Sustainable Energy and Building Solutions, and now called SEBS Engineer Inc. Basically, we are doing the design for the MEP, and of course involve some heat pump technologies, and also we do some solar projects.
Thank you. And next we've got Vinod Jagamohan.
Thank you. Hi, everyone. My name is Vinod Jaganmohan. I'm with Enbridge Gas. I'm here with the energy conservation team at Enbridge to talk about some of the programs that we have in the marketplace and how we're helping to decarbonize.
Thank you. And next we've got Amal Gina.
Hi, thank you to the OSEA and particularly to David Katz for having me over. I work for Simco Refrigeration, and what we do is we have tools to enable decarbonization. Tools such as heat pumps, thermal energy storage, and this is going to be particularly important to get rid of, natural gas, which is a huge problem. So thank you so much for having me to discuss this.
Now we had Daniel Roman on the list, but I'm not too sure if he's online or not, but he's not here today. Okay, now I think I'm doing this because for the past 43 years, I've been in the energy efficiency role. I used to say that I was quite lucky when I started my job at Alcan in 1980. It was the oil crisis. And because of the oil crisis, we all got into doing energy efficiency projects. Now we're 43 years later, and energy demand has grown significantly, as seen by the graph before. Efficiency is now even more important than it was before. And now the replacement of different energy sources with renewable energy sources is even more important than before. So to start, I'm going to start with no particular order, but I'll start with Philip. And the reason I'm starting with Philip is because, as mentioned before by some of you, heat pumps is a big thing moving towards the future. And Philip is going to tell us all about what he does with respect to heat pumps. So heat pumps are getting very popular, and let's see what you can do for us in the future. Thanks, Philip.
Okay, thank you. Regarding the heat pump, actually, myself, when I did my master degree in the later 1980s, and we started to research the air source heat pump. And of course, the technology at that time is nobody knows what is a heat pump. Nowadays, we government gives incentive, and everybody know or try to know what is heat pump. And what we did in the project that we especially last year, the year before, and in Toronto area, we designed a student dormitory which is in downtown. about 90 students in the student dormitory building. And what we do, we try to the first project, we try to use purely the heat pump, air source heat pump for the heating and the cooling. Because in Toronto area, we want to do the design, we normally need a backup with the the gas-fired furnace. So that's the first project we did. And of course, last year the government gave the incentive for the for the heat pump, and which myself to do in my home, and I believe many people they replace the air conditioner with the heat pump function, and that's the incentive given by the government. So what will be in the future, near future? Actually, currently we have technology first and foremost is for the heat pump, air source heat pump, which will be used in the residential sector of the building. The temperature, the outdoor temperature can go as low as -25, -30. Some people they claim they're going to -40, which will be used in the area in the northern Ontario. So that will change the design of the residential house or residential building. What we are going to do, we don't need gas to fire the furnace. We only will need the air conditioner, which have the heat pump function to supply the heating and cooling for the residential. So by doing this, of course, it significantly reduce the cost, because normally before we need two systems. One is first for heating by gas, and one is the air conditioner. Now we can use one system to provide heating and cooling. So this point I would say renewable energy or reduce increase energy efficiency is not necessarily increase the capital cost. So this is this system. That's one for the residential building, and also for the industrial sector. And now we have a technology which is can have the temperature go higher than 100 degrees C. What happened is, for the industrial area, probably I'm not sure how many people from the industrial sector, but there's a lot of heating process in the industrial sector, and of course, about 40% of heating process which need the temperature less than 200 degrees C. Before we have to use fuel like natural gas to heat the the steam or the whatever, then get the temperature. But now we have the technology which is use heat pump to like heat the fluid or whatever to up to 200 degrees C. So we talk about the electrification. So I think in the near future, we can use a heat pump instead of the steam boiler supply the heating for the process for the industrial process to reduce the gas consumption.
Okay, thank you. And I think I did not introduce Madan Gouchani, and you can introduce yourself.
I have already introduced myself.
You did?
Yeah. So, do you want me to talk about technology, our technology, or?
I'm going to come back to you. And I'm going to first question, and then we'll cycle again for another set of questions. So, for Hamal, who is from Simco, a refrigeration company, or ice rinks, I used to say. We'll start off by what tools does Simco have in the back pocket to decarbonize the industry?
Thanks, Anthony. So In order to decarbonize Ontario's energy mix, we need to first assess what is comprised of that energy mix. And once we do that, we have to determine the emissions generated from the energy mix. So Ontario's energy mix is composed of electricity, which is about 22%. And that 22% is 91% clean. So I'm not going to focus on the electricity portion of it. There is natural gas and petroleum, which is composed of 39% for natural gas and petroleum another 39%. Now, it's the emissions factor for natural gas that's really causing a detriment to the atmosphere. And that's what I'm going to speak to. It's speaking to the tools we have for decarbonization, and that's elimination of natural gas. So number one, and the one that's mostly used is heat reclaim from processes. Now, what we do is we analyze industries and we determine how much heat can be reclaimed from the processes in those industries. And we put it back, we channel it back to be used in the facility in terms of domestic hot water heating and building heat. So that's one of the tools we use. The second tool is the use of natural refrigerants. Now, our natural refrigerants have a global warming potential of 0 or 1, one for ammonia and one for carbon dioxide. With natural refrigerants, they have excellent thermodynamic properties, meaning they lead to a high COP. So you get a lot of heat out of using like a heat pump, and that because it's the heat provided over the work, right? They're cheaper than synthetics. They have low maintenance and energy costs, and they have no TFA issues to deal with. Now, what is TFA? A lot of you may not know. Trifluoroacetic acid. This is potentially toxic, and this is the breakdown that exists in synthetic refrigerants. So if you have any HVAC units, if you have any chillers that you have in your facility and they use synthetic refrigerants, beware. It's the TFAs in them that will degrade, because the synthetic refrigerants are known to degrade, and this TFA is potentially toxic. It can damage the thyroid and liver, and the TFA can also affect language development in children. So the leak rate threshold is about 30% in industrial refrigeration. It's about 20% in commercial refrigeration. Therefore, understanding the impact of natural refrigerants on your Scope 1 emissions is crucial. The third one is implementing natural refrigerant heat pumps. So when you go with an ammonia-based heat pump, you have a 0 global warming potential. What does that mean? Well, your Scope 1 emissions and your Scope 2 emissions are down to 0. And this is because your Scope 1 emissions are composed of your fossil fuel use and your refrigerant leaks, which is down to 0. And then your Scope 2 emissions is based on your electricity, the purchased electricity that you're using. And the purchased electricity is 91% clean. So all you have to do is supplement the 9% out of that electricity with thermal storage or with solar PV arrays. Now, the fourth tool we have is implementing thermal storage systems. Now, this is not really known or not really advertised too much, but thermal storage systems help reduce OPEX, CapEx costs, and further help with decarbonization. What is thermal storage? It's actually just you're trapping heat in a place and you're discharging the battery when the times are peaking, when the peak load is peaking and utility costs go high. So to conclude at this point, SIMCO does or implements three strategic ways to do this. We look at energy efficiency in your buildings. We look at VFDs, LEDs, implementing insulation in your buildings. Secondly, I just spoke about the thermal solutions that we do. So we do implement the thermal solutions. And then finally, we integrate renewables into the picture to get you to net zero.
Okay, thank you.
Thank you.
I think you went through all my questions by answering them ahead of time, so that's fine. There's one question I'll come back to everyone, but can you, Abinand, can you introduce your product?
Uh,
I didn't say this before, but I'm going to say it now. Give some indication to the audience of how your product is actually decarbonizing the economy.
So, as you know, vacuum tube collectors are very well known. They are less popular in Canada because of cold weather, and some maybe believes that because of cold weather we may lose lots of heat. But those vacuum tube collectors, they collect 90% of the energy of the sun to heat, 90% plus. So this is really a very good thing. But on the other hand, PV panels are already very well commercialized and very well used in our buildings. So with efficiencies of about maximum 23%. So the idea is to combine these two in a single system called hybrid PV thermal system and generate both of them in the same setup. So we have flexible PV panels. We can coat them on top of the black layer and on top vacuum and then transparent glass. And we already have commercialized this technology in the thermal part, and it needs just to be complemented with the PV. And therefore, we have systems, solar systems that can generate electrical energy and heat. So 23% electricity, and the rest, 90% of the remaining 70 and something percent, it will be changed into thermal heat. And it's very efficient. So therefore, we are talking about the technologies that are already commercialized and just combining those technologies based on our background in this respect.
Thank you. Thank you very much. And now we move to Enbridge Gas, who many of us would say are the major contributor to greenhouse gas emissions, not necessarily Enbridge, but fossil fuel. But I think we all want to know what Enbridge is doing to reducing carbon emissions or decarbonizing our environment. So I'll hand you over to Vinod.
Thanks, Anthony. So the first thing I always like to talk about is maybe the elephant in the room is why does Enbridge even get involved with decarbonization, lowering energy consumption, and saving on that? And the long story of it is, of course, on the short term, Enbridge profits from the use of natural gas, but in the long term, we actually are overall more successful by using energy as a more efficient operation. The expansion and upgrade of pipelines and assets is a very high costly endeavor. And by using energy conservation and some of our demand response programs that we talk about, we're able to offset this and really delay these upgrades that are needed to the grid and system. Within Enbridge Gas, we operate many different businesses. I'm personally from the Energy Conservation Department, where we deploy a number of energy conservation programs throughout the market for residential, commercial, and industrial customers to help offset the cost to invest in technology that will reduce your consumption. From a renewable point of view, Enbridge operates a large array of renewable natural gas projects. I believe we have about 50 projects across North America, with 12 of them located in Southern Ontario. In 2023, we recently finished a pilot with the City of Toronto to capture some waste, or RNG, from landfills and sites in the City of Toronto. In Niagara Falls, we have a very large collection plant that does over 60% of the RNG. I think collects about 24,000 meters cubed of natural gas is collected from that site alone in order to clean up the natural gas grid. In other provinces and in Europe, they are injecting RNG into the grid in order to clean up the natural gas and get a better carbonization. And yeah, so the reason why Enbridge does this is that it actually helps us in the long term. Although we understand natural gas is needed now, it is a precious resource, and certain industries will be easier to convert than others. Industrial sector might be a little more difficult, but in the residential commercial, there's technologies available now that weren't available 30 years ago that could help us get there.
Thank you. And follow up on what you just said, especially with respect to the RNG. The technologies that you're using to produce RNG, which is the renewable natural gas, are you using biomass, or is there for fuel injection sites. Can you tell us more? I know in the States there are different facilities where you can produce your own RNG or individuals and get injected into
the
pipeline
grid.
system. Yes.
So I'm not too familiar with all of the RNG activities at Enbridge, but yes, you're right. There is a combination of biomass being used for the generation, as well as we use the biomass, process it, and then inject it back into the grid to purify it. The the biomass is a more costly endeavor when you go into RNG. Some of the low-hanging fruit is collecting the natural methane gases that are being ejected from our landfills and sites from our garbage pollution. So that's kind of some of the low-hanging fruit that's being targeted right now.
Okay, thank you. I'll go back to Philip. One of the things that you are using for or proposing for decarbonizing is solar cooling. Can you tell us what you mean by solar cooling?
Okay, thank you. Yeah, myself, when I was doing research in Israel in 1999, and we started doing the project is called solar cooling. At that time, what we use is a desiccant solution to try to get concentrated, and then of course use the system for the air conditioning. That's it's the beginning of this century. And then, of course, before that, and there's a technology from the Japan, and of course, use the photovoltaic panel to assist in the air conditioning system, which is another type of solar cooling. So, summary, there's a two type of solar cooling system, major type. Of course, there are some variations. And the first products available nowadays in the market is like air conditioner. Use solar PV to assist in the air conditioning to get the cooling inside, which is one type of solar cooling. It's possibly like around like a 1 ton or 2 tons system for a household, and the price nowadays is about like 2,000 around, for the air conditioner with the PV system, PV panel assistant for the air conditioning system. Myself actually I work with David. We work for the CSA building. Possibly in 2018, and we installed we installed a few rooftop unit, one rooftop air conditioner unit, especially with 6 solar panels as assistant for the cooling. So that project was successful. At that actually I remember the product probably from Lennox or like some big lamps. So that product is already available. So it's that's the mature technology nowadays in the market for the solar cooling. And another type of solar cooling is we call the solar thermal. Basically, get the thermal energy from the solar, used for absorption machine. And there's 2 types of absorption. One is mature technology, we call the absorption chiller or absorption heat pump, which when we get the heat from solar, then we can assist to fill the or heat the fluid into the absorption chiller or the absorption heat pump, then get the efficiency from the solar. That's one. And another one is called the desiccant system. It's similar to the principle is similar to the absorption chiller, a little bit different because this system have been doing the research since probably the beginning of this century, and nowadays there are some big system being used in Arizona or in the southern United States. It's a good system. It's good for the climate where I have a lot of suns, so for the air conditioning. There's some pilot project is especially for the big application, the big project. Basically, these two type of solar cooling system, the air conditioner is for household, for the small system, small project, and solar absorption, solar thermal use, which for the big large project like in the right climate. So that's basically for the solar cooling.
Thank you. Thank you. Now I'm going to add something to that related to a full hybrid system. One of the things I promote and have built is a complete solar combined heat and power CCHP system. With this system, pretty much everything that's said here is combined on a utility scale. So you're producing chilled water using adsorption chillers to cool. And one may say this is an issue, but for 24/7 operations, not in Canada. It's not very economical in Canada, but for outside of Canada where there's 24/7 air conditioning, then there's a big need for that. So you're producing chilled water, hot water, and electricity and steam, and you're using solar to take the variable load on a base load. It's a system that effectively reduces the carbon footprint significantly. So my last question to the group is, how is your technology in the future reducing carbon emissions or reducing the carbon footprint? I'll start with Enbridge.
Okay, I think you're giving me all the hard questions, Anthony. So me personally, I work on the Enbridge Savings by Design program. It's a program for Part 3 buildings looking to improve their energy efficiency. So regardless of your fuel source, natural gas, or if you're going electrified solutions, you can participate free of cost. And our team will, through a variety of subject matter experts, some of them are here today, will provide an analysis on your building and use energy modeling to support some possible energy conservation measures you could consider. This is a one-day integrated workshop. It's free to participate. And at the end of it, we'll provide a summary and a report that kind of highlights the learnings from your workshop. You're not committed to go forward with the recommendations, but we hope that you're able to utilize them with your designs. So these programs, with my program and others in the Enbridge portfolio, are really helping to decarbonize at this level.
It's a question is for each. So you're next.
Thanks, Anthony.
Yeah.
So how we're looking to decarbonize is actually by implementing those 4 options that I discussed. But how would you get to start doing that? So we offer feasibility studies to look at your facility, and we can come up with a plan to do that. So in essence, we come in, we look at your facility, we look at your electricity use, your natural gas use, we look at your processes within your facility and determine from that what we're going to do to be able to reduce your natural gas or electricity use by using heat reclaim, by putting in heat pumps, boosting in that source heat to another temperature. We provide heating at 95 degrees, and that's from the first compressor. Then we can provide 185 degrees of heating, and that's provided to sanitation or for domestic hot water heating or what have you. So that's how we do it, by just looking at feasibility studies. We provide grant assistance, and that's how we get you to net zero. Because I think I've already discussed the 4 options.
Okay. Milan?
Basically, what we do is to generate electricity and heat, both of them in the same setup. Therefore, it's basically the same technologies that we already know, but because it's provided in the same setup, hybrid system, PV as well as thermal, hot water at the same time, electrical energy by PV in the same setup, we can generate highly efficient systems. Therefore, instead of losing 75 and plus percent of the light from the sun by PV panels, or losing 10% to 30% by existing thermal systems. Our system profits from combining the two and having the minimum losses from the two systems.
Okay, thank you. And Philip?
Okay, thank you. Yeah, of course, the heat pump technology will be, no, I would say probably in the future of the, especially the household air conditioning and heating, because we talk about electrification. So by doing the design, by use the products which we have a lower ambient temperature, so which we can meet the requirement of the Ontario law. It's we talk about, we use the products which is minus 25 degrees C ambient temperature, so which is basically in Toronto area and south, but in some northern area, the temperature is still too high. I mean, minus 25, minus 30, probably it's especially minus 25. So the technology will be going to lower ambient temperature. Somebody claim we have minus 40 degrees C ambient temperature, so which we can good to use in the northern Ontario, of course, someplace else. So let's give the wide range application of heat pump. So of course, by using heat pump, we have a COP of 4 around, and help to reduce the greenhouse emission, and of course have a lower for the carbon. And talk about the solar cooling, because the clean weather is not good for solar. I should have said that. So it's not good for solar, as good as in the South American. But there's still have an issue, because we might use a solar cooling to assist the air conditioning system or heat pump system. So that's when there's a more efficient technology come on the market, possibly in one day there could be make economic sense using the solar assistant air conditioning and the heat pump system in Ontario. But
Okay. Sorry, someone.
Yeah, we can actually, as I mentioned before, we actually use one in one of our projects, the CSE building. We use an air source kind of. Oh, that's not heat pump. That is air conditioning, rooftop air conditioning unit, which use a solar panel to assist the air conditioning. So the heat pump, of course, the same equipment. You just reverse the circle. So it's nowadays it's available for the in the market for the heat pump and air conditioning both.
Thank you for the question, but we're going to have a question period as
Okay, good.
just
Thank
of
you.
that. So
We're gonna have a question period shortly.
Yeah.
I'd like to put some closure, because I want to speak about Daniel Roman, who unfortunately wasn't able to attend on the panel. If you could.
yes, okay. Let's. Daniel was one of the panelists, but I believe David is going to speak on his behalf.
So Daniel Roman, I want to thank the panel, but I want to also suggest something that's really critical. When I push for things like solar cooling or absorption, and we did this study, Dr. Zhu and I, for the IESO, for the OPA at the time, we are getting $1,200 incentive to lower summer peak. And many of the technologies that we've just heard is able to lower summer peak. We did a study with the OPA on an absorption chiller that was going to be run on gas. It was going to be heating the hospital. It was going to cool the hospital, and it would have 27 kilowatt pump to facilitate the flow of the absorption. And we showed that to the OPA, and they said, no, we're going to get a York chiller at 247 kilowatts, and we're going to get a Viessmann boiler. So there are so many innovative technologies in other countries that we kept saying, not here, we have cheap energy. So that's part of it. When I met Miriam last year, he's saying, I teach so I teach at Humber on, solar, hot water, and here he's combining it. So I think we have to look at these technologies in the interest of where are we? What is the electricity incentive that we are avoiding that might be applicable? And I've talked to Dr. Zhu about phase change material. When I met him, I said, what is solar cooling? What, are you crazy? Like in Israel, they're doing solar cooling. So I just wanted to share that with you. And I've met you at getting ladies into the energy field. I mean, this lady controlled the Walmart Canada buildings. And Vaneth, we've done many things. Enbridge is one of the biggest renewable energy companies in Alberta. They have $4 billion in Alberta on wind farms, etc. And I just read at the Canada Decarb session, literally approach. I tried to get the gentleman here. Carbon capture next to a wind farm in Texas. And I was at Decarb Canada, the industrial thing downtown. And literally, even the Albertans, they're going to have, as Ian said, we're going to use fossil fuels, but we are able to capture the carbon and use it or reuse it. So I just want to thank the panel on this. Daniel Roman and I worked for over 25 years. Daniel invented the electronic ballast for streetlights. He literally took a Cobra head and a Etobicoke that was 90 watts, 70 watts for the bulb, and 20 watts for a core and coil ballast. And he invented the electronic ballast for streetlights. And we did tests here. We got the same amount of lumens on the street. We were able to get it down to 56 watts for the same amount of light. But he was way ahead of his time because Philips and transformers and the embedded people who have the materials already made want to do that. He has invented a new way of making solar panels with floating cells instead of soldered cell. And I've sent reports to him. There are major failures of solar panels, especially in the hot countries. He's had his product tested. I've had his panel down at the Mars. And so he would have spoken to what he is doing with regard to solar panels that produce more and last longer. And yes, they may cost more, but the question becomes, how is that in a life cycle analysis beneficial? And as far as his streetlights, and we've been in actually Commissioner Street at Toronto Hydro, because the streetlights were where he was started. He now has a streetlight that literally has solar panels on the top that open up to charge during the day. He stores the energy in batteries that are in the post. He has a smart LED light that's on the pole that runs. So you don't need to be on the grid for this. This is enough remote. In new developments, you don't need to run power lines to the streetlights. It has a display sign so you could have advertising, and of course people pay for that. So we have to get innovative around that. I'm sorry that he isn't here, but if anybody wants to know about his things, just see me. I just wanted to thank him for that.
Thanks.
And thank you all. Oh, I'll let you finish.
Thanks, David, for introducing that. At this point, I'm going to summarize and then have some questions from the floor. All the presentations so far has mentioned technologies that will reduce the electricity demand significantly by replacing it with green energy. The reason for this meeting. It's also to reduce the consumption of natural gas, as many on the panels are talking about. But one of the big problems that we face, and we probably face this as a country or as a province, is that these technologies are not easy to roll out. And as was spoken earlier, the 99% of SMEs have great resistance to implementing capital projects for this reason. So that I speak to the floor and ask the floor to help us to roll out technologies that will reduce carbon. And also, I agree with earlier on, embodied carbon, which I think is what one would call supplier-based carbon. The embodied carbon is very, very difficult to reduce. Decarbonization is a really big thing to change. It's not going to change because over 90% of our carbon use is in fertilizer and construction materials. So technologies that would reduce fertilizer use of carbon or construction material use of carbon would be significant on a large scale. These are not SMEs in that space, cement companies and fertilizer companies. Now, we definitely don't want to put too much out of carbon outside of fertilizers because fertilizers is pretty much why we're eating. It's food production. And if we were to take fertilizers out, our food production would fall and we would starve to death maybe, or get slimmer. Yes, so we have this other 10% that we're dealing with. So far, renewable energies have taken place on that 10%. There's displacement taking place. And so carbon emissions is going down because of renewable energy sources. But a big bang for the buck would be energy efficiency, because energy efficiency can get 30% off the big number versus displacing the 10%. I know I should have brought some graphs and so to show you this, but that's the nature of things right now. Now, the technologies that are here and that were discussed can be implemented, but it would be a good way, as Enbridge is supporting and Hydro One is supporting certain technology replacement, to get either governmental or large industry to support the replacement of technologies in more of a service concept versus capital outlay for small businesses or SMEs. So I open the floor for questions.
I think we're going to have a coffee break now and give everybody a stretch. Obviously, the panelists are here. The technologies around the room, from clean air to the building envelope. So the more time we have sharing and networking, because that's what we also want to do. And I thank the panel and Anthony.
Well, let's see how many people want to ask a question. We'll take 3 questions based on David's suggestion. We'll take only 3 questions. So if you're at a table, if you're at a table and you have a combined question, then we could ask it. Please.
I'm from Green Air Innovations, and what we aim to do is to bring awareness of these projects that are happening in different sectors of the green transition to the general public, because I frequent many places and the general public has very little idea of what is happening. And for anything to really take real hold, it has to also be at least awareness on the general population level.
Can you just ask a question without
I was
any?
wondering how can we get the public to know these things, these programs, these technologies, involve them more?
Well, I could answer, but I think I'll direct it to the panel.
Okay, sorry, I'd just like to answer that. I believe more education and more seminars like this need to take place with panelists like us, right? We need to get in front of everyone and we need to disclose what technologies we are putting out there. And that's first for me. But if you want to.
Is there another question? Or one answer, one question?
And I should just add that lack of awareness is a challenge, and it's, as proven by literature, is one of the obstacles for the spread of renewable energy. That's why that our company also, we started by education and by providing workshops for schools from grade 6 to 12.
Was there a second question?
This is particularly to Vinod Jaganmohan. You mentioned that you have invested a lot on assets. So what is the possibility of green hydrogen, for instance, and carbon capture, utilization, and storage?
I talked about it a little bit. So in terms of carbon capture, we have those RNG plants, so renewable natural gas that's being captured from waste landfills. Methane gas is a natural byproduct of decomposition. And we have some capture technology that's being utilized to capture that and contain it. There is a certain amount being pumped into the grid to overall clean it, but it's a very low percentage. And in the future, it may be mandated that, I know in Quebec, for example, they're mandated to get to 1% of all of their natural gas has to be of an RNG nature. So in Ontario, it could be expected that in the future that we'll get to 1%, eventually to 10% and higher as we move on that.
In respect to hydrogen, hydrogen cannot be placed by itself at high concentrations in this current grid. The corrosive nature of hydrogen, or the reactive nature of hydrogen, cannot go in the pipelines as it is. So the maximum you could embed hydrogen in natural gas lines, and at the same time you're cutting back natural gas. Any other questions? If that's the case, then David, you have the floor. Thank you.
Thank you all.
Thanks, David.
As I said, we're all volunteers. We welcome the efforts of the panelists. We're taking a coffee break now. The next panel is at 10:50, so you have lots of time. Around the room are some of our sponsors and technologies. We're happy to share them with you.